Imagine moving your mouse and seeing the cursor just glide across a 4K monitor, like absolute zero lag. But the actual computer you're controlling is sitting in a server rack over a mile away.
Yeah, it honestly sounds like magic when you first hear about it.
Right. Well, today we are taking a deep dive into exactly that. We're unpacking the specs of the Smart-AVI HFX-KM-RX-S HDMI 2.0 KVM fiber receiver. We really want to figure out how it physically pushes that massive amount of data without losing a millisecond.
And I mean, the sheer volume of data we're talking about here is just staggering. You've got a full 4K Ultra HD signal running at 60 hertz plus stereo audio.
And USB controls, right? Like your keyboard and mouse.
Exactly, yeah. That's what the acronym KVM stands for, keyboard, video, mouse. And it pushes all of that up to 2 kilometers, so about 1.2 miles away.
Okay, so normally if you tried to push raw 4K video and all those peripheral inputs over thick copper wire for a mile, it would just degrade into this unusable, laggy mess.
Because electrical resistance, right?
Oh, 100%. It would be a complete slideshow if you got a signal at all. Yeah. I always used to think of these extenders as just incredibly long cords, but looking at the mechanics here, it's less like a long cable and more like having this highly trained proxy sitting right at the computer, just instantly mimicking every move your hand makes from a mile away. So how on earth does it bypass all that electrical degradation?
Well, what's fascinating here is that it actually abandons electricity altogether. It swaps it out in favor of light. So it uses single-mode fiber optics.
Wait, really? So no copper at all?
No copper. Unlike older cables, those heavily shielded ones that constantly fight electromagnetic interference over long distances, this tech uses a laser to shoot data down a microscopically thin glass core. The signal stays perfectly clean because it's literally just a direct beam of light.
Oh, wow. So when the spec sheet highlights an ultra-low latency of less than 1 millisecond, that delay isn't really a bottleneck of the hardware processing the signal.
Right, no, it's essentially just limited by the physical speed of light traveling down that tiny glass tube.
That is wild.
Yeah, and to our human perception, where our reaction times are measured in hundreds of milliseconds, it feels totally instantaneous to you. Yeah. Plus, doing this over a single, relatively cheap strand of glass is just a massive leap from the huge cable infrastructure you used to need just across a single building.
Okay, so fiber obviously solves the distance and the speed problem,
Yeah.
but here's where it gets really interesting to me. What happens if, say, someone accidentally kicks that fiber cable? Or if there's a micro drop in the network?
Yeah, the reliability question.
Right, because if I'm doing a huge data migration, or maybe I'm hosting this high-stakes interactive conference, I can't have the server just kick me out over a 1 millisecond hiccup. I mean, why invest over $550 in this physical receiver hardware when you could just load up a software-based remote desktop for way less money?
So that brings us to a really crucial hardware feature here. It's called uninterrupted KVM emulation. You see, software screen sharing totally relies on the operating system's network stack.
Which can be pretty fragile, honestly.
Exactly. If your software connection drops for even a second, the OS registers that the user disconnected. And in a mission-critical operation, that can instantly crash the active session or lock the whole machine down.
Ooh. So how does this physical box actually stop that OS-level crash from happening?
By basically spoofing the hardware connection, the receiver provides uninterrupted emulation directly from your transmitter unit. So at a mechanical level, it's constantly sending the proper USB handshake signals to the host computer.
So the remote computer literally never realizes the human isn't sitting right there plugged in.
Right, exactly. Even if there's a momentary physical disruption or some weird network spike, that hardware emulation just holds the connection open. The server never deactivates the session, which keeps your workflow absolutely rock solid.
Wow. So what does this actually mean for you as the listener?
Well, whether you are architecting some complex remote server farm or you're just insanely curious about cutting-edge AV tech, this receiver really proves that physical distance is just no longer the bottleneck it used to be. It really does. You can manage a flawless, crystal clear 4K workflow from completely different buildings using the speed of light. It completely redefines our relationship with computing hardware, proving that absolute control doesn't require physical presence anymore.
Exactly. Which really leaves us with a final thought to ponder. If we can seamlessly control mission-critical 4K environments from over a mile away with less than a millisecond of delay, basically operating at the speed of light, how long until physical proximity is just completely decoupled from human operation in every industry on Earth?